Topic for the video lecture is basic configurations and its associated bus timings. Here we have two types of configuration, which is the minimum mode configuration and the maximum mode configuration. Coming to the minimum mode configuration is nothing but the 8086 will be a standalone system. We don't add or interface any other processor or any other coprocessor with the main processor, that is 8086. And here you could see the pins associated or the interrupt interface pins, the DMA interface pins, the mode selection, whether it is in minimum mode or maximum mode. And here we have the address and data as well as the status lines. And we have certain essential signals which is related to the memory and IO operations. And this minimum mode 8086 system, as you could see from this block diagram, here you have the 8086 which is interfaced with a clock generator, which is an 8284, which will generate the clock. And here you have the minimum maximum to be connected to the VCC to support the minimum mode. And we have the memory slash IO. We have interrupt acknowledgement signal, read signal, write signal, data enable, and data transmit receive, bus high enable, and the address latch enable. These are all will be active during the minimum mode. And you could see certain latches, transceivers, which performs both transmission and reception, as well as we could see certain memories, which is RAM on EEPROM, as well as we have the IO. And we have both the address bus and the data bus for transfer of address information and the data information. So the minimum mode system will be such that it is a standalone system where you will be requiring a clock generator to generate the clock. And this can be better read from the timing diagram aspect. So we can read two timing diagrams, which is a read cycle timing diagram and write cycle timing diagram. So as usual, it is represented with the clock, which indicates the T states, and you could see the before the fourth T state there is a TW, which is a wait state. And here the address latch enable, which is initialized in the first clock T state, and the address and the status information is put in the first T state, and it is latched in the first T state, which is latched, that is address is latched, and the status information is put up right from the second T state till the fourth T state, as well as the data, that is A15 to A0 is latched in the first T state, and we have the data information right from the almost at the end of the third T state till the fourth T state. And whenever the read signal is activated, the bus will be reserved for the data in, and the data will be placed in the data line. And similarly, the data enable should be made active. This is an active low signal to read the data, as well as the data transmit receive should go low as it is a read operation. And coming to the write cycle timing diagram for the minimum mode, here also we have very similar to the previous timing diagram, which is the retiming diagram, except that here the write signal should go low. It will go low from the almost mid of the second T state, and the data enable will also go low, and the data transmit receive will remain high as it is a write operation. And here you could see that the higher order information, address information is latched during the first T state, and the valid data is placed right from the end of the second T state. And maximum mode 8086 system, we have, this is the overall pin associated, and here also we have the interrupt DMA, the mode selection, and certain memory IO and control signals. And here Along with this main processor, you will be having the other processor such as the coprocessor, where the bus system will be shared both by the main processor and the additional processor interfaced. Here this is a diagram where again you could see a clock generator uh, which will generate the clock, and along with that you will be having a bus orbiter which is an 8788. So this will be generating the control signal. So here we don't have an involvement of direct read or write. We have the IO read, IO write, memory read, memory write, as well as we have the advanced signals also is associated, but of course it is not shown over here. Advanced signals is also there, which means that it will be generated in the previous T state. And as usual you will be having the latches, you will be having the memory, but the very important thing is the control information will be playing a major role, as well as with the status lines which is S0, S1 and S2. And this is in the maximum mode. You have either a numeric coprocessor or any other processor, any IO processor. And here the memory, address bus, data bus or shared resources between this processor. And we have a bus controller chip which is 8788, and the status outputs S0, S1, S2 from the processor are given as input to 8788, and outputs of these bus controller will serve as a control signal, as I mentioned already. Something like data enable, data transmit receive, IO read command, IO write command, memory write command, then the memory read command, ALE, etc. And again here also you could see the read timing diagram for the maximum mode, and here the data information is placed almost in the T3 and T4 state, and here the status line S2 and S0 will come into active, and it remains active for almost for the first two T states and remains inactive for the third and fourth, and again it becomes active. So this is also very similar to the previous thing, except that the control signals are changed as memory read command or memory write command. As it is a read, it is shown with the memory read command. And coming to the next one, so here S2, S1 and S0 will tell you what type of function is being performed. It's an interrupt acknowledge, IO read or IO write, whether it's a halt or it is an opcode fetch, it is a memory read or memory write, or it is remaining passive. And coming to the memory write timing in the maximum mode, again this will also play here an important role. Instead of the write, we have a memory write or IO write, and the remaining things almost it plays the same thing, and once again the status lines S2 and S0 will come into the picture. So which remains active for the first two states, T states, and it goes inactive at the end of the second and the third T state. Data transmit and receive will remain high or low depending upon the write and the read operation respectively. Thank you.